Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akib bin Hasanuddin and my test number is 202592. So for our group, our chosen application is rice cooker, and for my part, I want to discuss a little bit about rice cooker. What is the function for, how does it work, and how can we relate dynamic into the rice cooker. So the first consumer-oriented rice cooker was invented in 1945 by Mitsubishi, and the first automated rice cooker was invented in 1956 by Toshiba. So the purpose of invention of rice cooker is just to simplify the process of cooking rice. So how does the rice cooker work? So first, electrical energy from the plug will transfer into the rice cooker and change into heat energy. So the heating plate will heat up the rice and water that inside the inner pot of the rice cooker from below, and the inner pot is made of metal such as aluminium and copper, which good at conducting heat. So the heat will transfer uniformly inside the inner pot, and rice cooker are insulated, so this will speed up the process of rice cooking because there are minimized heat loss to surrounding. And then after heated, water will change into steam and will be absorbed by the rice, and because of all the water has been absorbed by the rice, the temperature inside the inner pot will increase, and this will trigger the switch and turn off the heating plate and prevent the rice from overcook.
There are two thermodynamic laws used in the application. I'm going to present to you the first law, which is energy can be converted from one form to another, and energy cannot be created or destroyed. To understand further, we'll use the equation delta U equal to Q plus W, which is delta U, total change in the internal energy of the system. Q is a heat transfer to or from the system, while W put done by or on the system. And there are also four types of thermodynamic process, which is isobaric, isothermal, isochoric, and adiabatic. Isothermal process, which is temperature is kept constant, for example a refrigerator. Next, adiabatic is the no heat occur, for example isolated system in the heat engine. Isobaric process with the pressure kept constant, for example like the boiling water in an open space where the pressure atmosphere is kept constant. And last but not least, the isochoric, where the volume is kept constant, like the pressure cooker. In this application, the rice cooker use the same like pressure cooker, which is isochoric process, where the volume of the rice cooker itself is being kept constant, so no work done at all, while the heat transfer is being conserved from the power supply until the end. I will show you the diagram to further understanding where the electrical energy is being converted from the power supply to the heating plate, to the inner cooking plate, and last but not least to the rice itself throughout the process. So the energy is being conserved throughout the process.
As Daya said, that energy cannot be destroyed, but it can only be transferred from one system into the other system. And the second law of thermodynamics states that every energy has its quantity and its quality, but the energy will flow from the higher concentration into the lower concentration. For example, like the heat transfer energy. The heat transfer energy will transfer the energy from the hot region into the cold region, and it cannot be the opposite way. And the total energy after and before are not the same due to the loss heat to the surrounding. And how can we apply this process into the mechanism in the rice cooker? Okay, so first the heat will be transferred from the heating plate, which is the hot region, into the inner pot, which is the cold region, and the heat will make the rice cook well. And after a few hours, there are some heat loss due to the heat transfer from the inner pot to the surrounding, because after a few hours, the inner pot will be the hot region and the surrounding will be the cold region, and the heat will be transferred from the inner pot to the surrounding due to the different concentration of the temperature. And as we see that the heat loss, the temperature of the rice will be cold after a few hours. That's why the second law of thermodynamics can be applied into this mechanism of rice cooker.
Thermodynamic analysis of rice cooker, we choose to use a rice cooker with power input of 400 watts and the power output of 240 watts. And total 400 ml of water is used to cook the rice, and the rice will take approximately 30 minutes to cook completely. In this analysis, I'm going to calculate the efficiency of the rice cooker and also work done during this process. By using a formula, we obtain that the efficiency of a rice cooker is only 0.6 or also equal to a 60%, which is lower than a 1.0 or not equal to 100%. This is because that the power output 240 watts is lower than the power input. The power output is lower in this case is because that some of the energy is transformed into another energy, and this is called as dissipation of energy. In this case, when the current is passing through a cable, the cable inside has an electrical resistance. Some of the energy from power input is needed to overcome this electrical resistance, so some energy is lost. And this energy will be lost in the form of heat, and this actually obeys the second law of thermodynamics, in which the particle of energy will be moved from a higher region to a lower region. In this case, heat is lost to a surrounding is because that the surrounding has a lower temperature and also lower energy. This process is also follow the first law of thermodynamics, in which the energy will not able to destroy or disappear. In this case, some of the energy is used to overcome the electrical resistance in the cable. The energy just transforms into another form but does not disappear. The operation of a rice cooker is actually easy, in which the electrical energy from power supply is transformed into a heat energy by the heating plate, and this heat energy is used to boil the water to the steam, and eventually the rice will be cooked. The heat energy Q is obtained by multiply the power outputs and the operation times. There are two states in this system, in which the water, which is the initial state, and the steam at the final state. And by using the table A4, we can obtain the internal energy of the initial state and the final state. Since the system in this process is a closed system, means that there are no mass will be crossing around the boundary, and we'll use the energy balance equation of energy inputs minus energy outputs is equal to a change of energy in this system. Since this process is an isochoric process and there's no change of elevation of velocity, means that we does not need to include the boundary work and the change of kinetic energy and potential energy in the equation, and we obtain the final equation as this. And by substituting the value, we can obtain the work done in this process is equal to a negative 428.47 kJ. And this negative indicates that the work is done on the system and it is actually the work input.